All right. First of all, everybody, thanks for coming. It's exciting for me. It's my first time in India presenting in Pune, so it's really fun. My name is Sasha Parfenov. I'm an Apache Apex committer, and I'm one of the earliest engineers at DataTorrent. I've been with them through before Apex became an Apache project, while it was still a closed source system. I've seen it develop over the time. Then it became an incubating project, and middle of last year, it became a top-level project. So it's been a very exciting time. Before I jump into the talk, I'd like to get to know you a little bit better. So maybe by show of hands, how many of you are already familiar with Apache Apex and have worked with Apache Apex applications before? So a few of you? Okay. So a good number of you still haven't seen all the ins and outs of Apache Apex. We've already had some excellent presentations earlier by Pramod and Amol and others about the details of Apex. But what I'll do is I'll go over do a quick introduction to quick overview of the Apache Apex, and then I'll jump into a demo. I would like to show you the capabilities of a DataTorrent RTS console, as well as the real-time components, including the visualizing metrics for your applications and visualizing your data for your applications. If we have extra time, I could cover some additional technical topics, but I think the time is really short, so we may want to pause for Q&A. If you have questions at any point in time during my talk, feel free to pause. I'll try to answer them. So Apache Apex, you've had the introductions, but basically it's a great platform for developing your big data applications. The applications which can be distributed and they can be used to process streaming and batch data. As you've heard earlier, there's a number of excellent reasons to use Apex, especially when compared to some of the other offerings that are on the market today. It's extremely scalable, where I've personally participated in the projects that demonstrated billions of events per second throughput. We've had also a POC with Google Cloud where we've demonstrated over 500 million events, and there's a blog written posted by Google on that. We've had customers like Capital One who needed extremely fast pipelines that could do end-to-end computation in just a few milliseconds, and they were hoping to get to like below, I think it was 40 or 50, and we managed to do 2 millisecond end-to-end computations. So the platform is extremely fast. It's fault tolerant. It automatically recovers from failures. If one of the nodes goes down, a process gets killed, it can recover and keep on going. It's also Yarn native. It makes so if you already have a big data ecosystem, which is typically most of our customers do, if you have an existing Hadoop cluster, it could be anything that running in the cloud, on-prem. The Apache Apex is compatible with it, and it can run directly on your existing solution. So the installation is trivial. It installs within seconds, and you're up and running. It's also developer friendly. You don't need to create new modules. You can reuse your existing ones if you've written them in Java, and you can take like lots of existing business logic and reuse it inside operators. So that's really makes it really friendly for development. And in addition to that, you don't need to write all these connectors. You saw a number of systems that people want to connect to and read events from, or write files to some other downstream system. We've already provided a lot of these operators with a Mulhar library. There's a number of connectors for inputs and outputs, a number of existing compute operators, and there's also a lot of templates to get you started. And we have integrations with a lot of Apache projects, including Calcite, Samoa, Beam, and others. And there are good talks that we've already had and coming up on those topics. So just to give you a quick overview of what I'll be discussing, you've probably seen the slide earlier, but at the very bottom, there's your Yarn clusters, any flavor of Yarn and Hadoop clusters we support. On top of that, you have Apex core running, and on top of that, you have the operators, Mulhara library, and some of the free application templates we provide. The area that I'll be focused on today is in this blue box, which is part of the RTS platform offering. It comprises of the graphical assembly tools, management and monitoring tools for your applications, and including the real-time data visualization dashboards. So that's going to be the bulk of the conversation. The use cases, everybody will be talking about use cases today, particularly in application track. But typically, it starts out as either streaming events, or it could be even batch data that periodically gets copied somewhere from messaging queues like Kafka or Solus, or from your databases or HDFS. Then the data flows into the Apache Apex platform. It gets processed as a series of operators connected together, part of our application, which is called the DAG. And then the events are either written out to one of the downstream systems. Again, probably records on HDFS, maybe Cassandra stored on Amazon S3. And at the same time, you can perform real-time visualizations on this data.
Where does DAG come?
Good question. So it leads into my next slide. DAG is what we refer to as the Apache Apex application. It stands for Directed Acyclic Graph. Directed Acyclic Graph. Recently, we've added a delayed operator support, which means you can do cycles. It's to enable machine learning and some of the other use cases, but that's the name that we're still sticking with, because it's just a convention that we've used for a long time. So just to give you a quick idea about how the applications are composed, you typically have operators here, which are your business logic. They're the processing components, and they're connected by these directed lines, which are the streams. So that's how the application is composed logically. So you'll have something that's reading input, parsing it, maybe doing some computation, and then writing the output somewhere. So this is an example of a really simple application. And as Pramod talked about earlier, they typically built just like the example shows here, using Java code, and this is the compositional manner of constructing them. There are other ways. I will look at one other way, which is the visual assembly using our console in just a moment. And finally, I'm covering these points because the questions may come up later in the presentation. When the applications gets deployed, there's certain key things that happen. So I'll be showing you the DataTorrent RTS console. It's represented by the green box on the top right here. The console is your visual interface to the platform. It's connected to the gateway, which is it's a server that runs on one of the edge nodes, and it's the server which is talking to the resource manager. The resource manager here is your yarn. So it's the one that's provisioning all the resources for all your containers. So the gateway talks to the resource manager, and then in turn the resource manager starts allocating containers. And for every Apex application, there's a primary container which is responsible for orchestrating the rest of the flow of your application across the Hadoop nodes, and it's called the STRAM. It stands for the Streaming App Master. And here in a diagram, you have 4 Hadoop nodes which have various containers deployed on them, represented in green. And we've briefly covered it earlier, but basically your data isn't necessarily sitting on any one of the Hadoop nodes. All the processing that we're doing is in flight and in memory. And so here's a blue line of data coming in, and it may go to one of the containers on one of the Hadoop nodes. That would be operator 1 from the maybe earlier example that we saw. And then you could have additional inputs like the one here coming into the second Hadoop node in operator 2, and then they're joined together into operator 3, and so the flow continues, and basically your data is flowing around from Hadoop node to node, from container to container. And if you want to improve or optimize it, sometimes you can co-locate them in the same container. and by changing stream locality. So just wanted to give you a quick overview of what the application looks like and logically when you're building it here, and also how it looks like when it's deployed physically in the cluster, because all these things we're going to look at. So let's get right into the demo. All right. What you're looking at here is the DataTorrent RTS console. It's this welcome screen. It's part of the Learn section, and it's typically the first place that you would end up after installing RTS, or if you click on the DataTorrent logo in the top left corner. If you look at the main areas, they're basically links to our documentation site to help you get started. So if you installed it and you're not sure what to do, you can check out documentation on how to run demos. It'll take you to our documentation website, docs.datatorrent.com, where you can find out the details on that, and you can discover more details about DataTorrent RTS and how to create different apps. So I'll quickly go through some of the high-level features available in the console, and then we'll spend a little bit more time looking at the monitoring and visualization areas, which are the key for this talk. So some of the interesting things that are available, first of all, when you're installing the RTS platform, you might want to configure it. So the UI allows you to do all the configurations. It allows you to check all the settings that you've currently set, as well as change system properties, enable services, things like that. It also, the RTS provides other features beyond what native Apex gives you, and gives you control over things like user management and security. It allows you to also rerun the installation one more time if you want to reconfigure your system. And it gives you things like alerts, where you can set alerts and monitor your running applications. Oh, okay. I was told to zoom it in a little bit. Hopefully this helps. Some more? Okay. Try to do our best. If some of you are having a hard time seeing in the back, we do have a few chairs available up front, so feel free to come up so you can see it better. All right, so that's the configure section. Another interesting area that we recently introduced in one of the recent releases of DataTorrent RTS is the App Hub. So the App Hub is an online repository of application templates and demos that you can use to get started. So all of these are hosted online on one of the DataTorrent servers, but you can copy them locally and import them through the UI. So for example, let's say you have a use case. One of the slides we saw earlier, let's say you're trying to read events from Kafka and then do some kind of processing and write them to HDFS. So you might want to start with an application template, for example, this one here called Kafka to HDFS Sync App. It gives you the skeleton of your app to get you started. It has the Kafka input, it has the HDFS output, and then you can start adding your own operators in the middle and start writing your business logic, so you're most of the way there when you're starting. So the App Hub, I think we actually have a talk about it coming up later, so I won't go into too many details, but I'll tell you that for each one of these tiles, which represents typically an application package, and usually we try to keep one application to a package, you can also click on them and you can see all kinds of additional details, tutorials about how to run this app, and as well we provide the links to GitHub to get you started, to download the source code for these apps, and additional documentation about these apps. So that's App Hub. And if you want to, again, as I said, if you want to import one of these apps, you just click Import here, or you can go inside one of these tiles and click Import on this page. When the application import finishes, you'll be notified that it's available. So it just finished the import, and you can see that it's available here. So that's the online App Hub functionality. Next, you probably want to know, okay, well, if I either take an app from the App Hub or I built my own, compiled my own application, and when you're done, the target output is typically an APA package. where you go to upload and manage them would be in the development section. So we have an area here which is called application packages, where you go. So the APA is the application archive for an Apex application. It's just like a jar file. It's a collection of all the resources and code that you need to run Apex app. Here you have a list of all your applications that have been imported. And as I said earlier, you upload these packages called the APAs. It can have more than one app inside it. So we provided multiple views. You can actually either go by applications list, or you can click on the tile view, and each larger tile here, for example, DataTorrent dimension demos, would be representing a single package, and all the apps listed here are all the apps inside that package. And as you can see, some of them, like HDFS sync app, has a single app inside it. So you have multiple views provided here, and of course you can search and filter for your applications. Now, if you want to run these apps, you can, for example, just press launch and launch one of these applications directly. If we continue to saying launch, it'll start running, and then you have a running application instance, which is what we talked about earlier. It gets deployed to your Hadoop cluster and starts executing the code. Alternatively, you may want to configure, you may want to create a configuration. So the way you would do that is, let's say we wanted to configure one of the common, really simple examples with just a few operators to get you started we have is called PyDemo. So what you can do is you can try to configure a PyDemo by saying configure and create new configuration. You provide some kind of name for this configuration and say create. And what that allows you to do is it creates a separate, so it's a concept called configuration packages. It kind of goes along hand in hand with the application packages. It allows you to add custom properties that override the properties inside your package. So for example, if you wanted to, let's say that somebody created this package and they've provided, for example, every operator here has a memory of 256 megabytes. You may want to override that in your particular configuration before launch. So you can put the property here and provide a different value. Like let's say we'll give it 512 megabytes. You can save this configuration, and then you can launch your app. Once you've launched your app, the application will be running with these with the settings that you've provided. So that's the applications and how you configure applications, and by creating these configuration packages, when you launch them, they become running app instances.
So what does this PyDemo do?
So this PyDemo application is really simple. As you can see, for every app and configuration, you not only have the details of the name and also the package, but you also have this logical DAG here. So here we're producing random numbers as input, and we're performing computation. We're using a Monte Carlo method to determine the value of pi, and we're printing the output to the console. So that's what this app is doing. It's just a simple demo app. It has a generator. It does some calculations and writes output to the console.
So in configuration, what all you can?
You can change you can change every property for your app. All the properties and all the attributes. So attributes, for example, include things like they all have ATTR in their namespace, and they are typically memory settings, a number of other settings that you see here. The properties typically refer to the operator properties, and they are things like when you develop a particular operator, let's say the one that's calculating the value of pi, you may have some kind of default base value that you're starting with, or max value that you want to use for your random number generation. So these are the operator settings. You can change all these. You can also so you can configure them all here in application configurations, but all of these are also configurable at runtime, and the console allows you to do that. And we'll take a look at that in a second.
So in the template, do you give guidelines for each parameter, like what it should be, what range?
Yes. Well, it's very specific to the application. But yes, in the templates, we do document the ones that we have on the App Hub. They will explain what the application does. We typically try to add even a video to explain how it should be launched and run.
Yeah, for each parameter, what would be the boundary?
Right. Not every parameter may be explained. Some of them you may have to jump into the source code, which we also provide, and you can look at the source code though and figure out what exactly it's for. But we try to document all the relevant things that you need to get
Source code is in
going.
what language?
Source code is in Java. Yes. Okay.
One other question.
Yes.
Difference between the properties and attributes, if I understand it correctly, properties are more of functional aspect of
Yes. They're functional parts of the program, and attributes apply to the platform itself. Yeah, like how you change the operator size, maybe how you change stream locality and other things.
So these are all non-final properties, right?
Which ones?
These are all non-final properties,
Non-final.
right?
Yes.
Non-constants.
These properties, you mean these here?
Yeah.
Those properties are set for the package. So all the applications that reside in that package will inherit those properties and will be launched with them. As soon as application is instantiated, whatever property it fell to, like either it's set directly in the operator or it's set in the package level. So you have hierarchy of like how they get applied. But basically, it gets applied and it's in that running app. It's written as it is. But you still have ability to change it later, even after it's instantiated.
So when you say Java, is that J2E?
It's not J2E format. It's just regular Java, how the applications are written. Okay, so we've kind of seen a little bit of the regular Java apps. One quick thing that I also wanted to show you is that besides, let's go look at application packages. We also support JSON format. So this is something again that I don't have a lot of time to get into. I just wanted to show you something quickly. So let's say we're talking about the same Pi demo. If it's an application that's constructed in JSON, what it means is you can use our visual application assembly tool to develop it and to modify it. So the way it works is you have a UI tool that has all these operators in a modifiable canvas. You can actually move them around. You can on this monitor it's not very clear, but you can actually take the streams and drop them and connect them to particular operators. You can also choose from existing library of existing operators and add new operators. Let's say we wanted to instead of writing to the console, we wanted to write to HTTP location. So what we can do is we can take the output and connect it to the HTTP. So I won't modify this app, but you basically have a complete freedom to given a package. A package contains all the source code for all the operators. We inspect that package, we load the list of available operators, and then it'll allow you to construct your apps dynamically in the UI, so you don't even have to open the IDE. But again, if there's an operator that you're not finding, you may need to go back to the IDE to develop the custom code and then bring it into the app package. But once it's developed correctly, it can work with our visual application assembly tool, and it can be a really handy way to quickly prototype some kind of use case. So that's another way of building apps. And as we mentioned earlier, there'll be other talks about high-level API and other ways of constructing Apex apps. Just wanted to quickly show you this capability. All right, so once the apps are launched, you can go to the monitor section where you can view and monitor these apps. So first of all, you'll notice that we have all the cluster statistics. So these are all the apps running in aggregate. You can see the details about how many cores are being used, how much memory is allocated currently, what's the peak allocation, the number of apps that we've launched and stopped, and the total number of tuples that are being processed per second in aggregate across all the apps. So if you're running multiple apps, this is a really good summary view, kind of a quick glimpse into what's going on right now with all your apps. And then below, you can see a list of the running applications. The one that we launched is right here. You can actually inspect each one. We'll jump into one of them in a second. But you can also manage them. You can just say kill and stop the applications. Now, let's jump into one of them. I'll just show you a few quick features which are specific to being able to visualize the application metrics. So let's pick up. There's one of the larger demos we have is a telecom demo, and now we're looking at a view of a running application. So again, you have the same kind of summary that you have for a cluster, except now this is specific to one app. You have the application name. You have ability to control the application. You can kill it. You can restart it later. You can jump directly to its logs. All the performance metrics are indicated here, so you can immediately see it's in a good state. It's running. You see its window IDs, which are useful when you're developing the app and you may want to troubleshoot what's going on with it. You also see the number of tuples it's processing currently. As you can see, these numbers are changing live. The total processed and total emitted is right here as well, and how much memory it's using and how many containers have been allocated to this app. So all these numbers are immediately available in your application overview. But as these applications run, especially run over a long time, you may want to have a glimpse of how it's been doing over time, but not go all the way down to the log levels, but just kind of get a quick idea of how the application is doing at high level. So for seeing how it's doing and being able to troubleshoot it quickly, we have this view called Stram Events, which is also updated in real time. And here you can see all the key steps that are happening in the lifetime of your app. So here, all the events we see are in blue color, which is indicating they're positive things that are happening. All of them are starting operators or allocating containers. But if we jump to one of the other apps, maybe we'll get lucky with one of them. But some of the apps may have other events, like for example, here's a container that exited. You may want to view information about why that happened. And also in the cases where you have apps that some apps may have other issues. I don't know if I'll be able to just find one at random. But if the app, okay, so all these are running well. But if the app has problems, you can always see links directly to the application logs. So immediately from the Stram events, you can jump directly and troubleshoot the problem. You can see the summary of what's going wrong. You can go really deep into troubleshooting the application. This is a really convenient feature because typically troubleshooting distributed app is a really complex task. You have to go across multiple nodes. You have to find your logs. It's really difficult. This is one of the things that we excel in, making operationalizing your Apex applications, making it easy for you to figure out, to not only develop them, but also troubleshoot them and see what's going wrong. Another thing I wanted to show, which is one of the other visualizations we have, is a logical DAG view of a running app and the real-time metrics that are being updated on this DAG view for this application. So here, again, we're looking at a larger app. It's a telecommunications demo. What the app is doing is actually bringing in events from different call centers for a telecom provider, and also taking call data records for that telecom provider, aggregating them, generating dimensional computations on them, so you can view all kinds of key indicators for those for that provider. Here you can kind of move around on this mini map to see the DAG in its entirety, or you can use Option and kind of zoom in and out. I don't know if you can see it too well. It might be too small on the screen. But you can see the DAG in its entirety. You can also, for each one of the metrics, you can change the numbers. Hopefully you guys can see this in the back. But you can change the metrics that are being displayed. So for example, the top is currently indicating how many tuples have been processed by that operator. You can change it to, for example, number of containers allocated for that operator, or the heartbeat, or the total process by that operator. And again, all this is changing in real time. So this is a really useful way to see how the application is performing. Also, another neat feature, so I'm going to zoom out a little bit, is to be able to troubleshoot performance bottlenecks in your apps. And again, distributed app, this is a really tough thing to do, especially with a really large one where it's deployed across multiple nodes, has multiple containers. You're not sure what's going on. So we provide this feature called the critical path, which you can enable. And it shows you in red the critical path for your application. What it means is it's the path that's the slowest to process the computation end to end. So this is the path that has the most delayed. Probably the operators in this path are the ones that you want to focus on if you're trying to troubleshoot your app, because those are the ones that are slowing you down the most. If the application is well tuned, you will see the critical path updating in real time, because there's not much difference between like one flow or the other. So you will see it jumping from branch to branch, because it means that there's the delays are really small. Like here I'm displaying latency in milliseconds in the top field, and they're really, really small. So we're seeing latencies of just like a few milliseconds in most cases, and maybe in the hundreds in some of the operators, but still milliseconds. So that because it is jumping back and forth, you can tell this is probably not, it's fairly well tuned, or at least all the computational paths are fairly equivalent in this app. So that's another useful feature. And another thing that, so this is the logical view. You can also flip to the physical DAG view, and you can see exactly the same topology, but now from the perspective of how it's actually running on your Hadoop cluster. And here, what you'll see in some of the apps here, it's very, very similar. The colors around each operator are indicating which container it's deployed to. So different colors indicate different containers. So you can quickly visually glance at it and say, okay, these are all running in different containers. Also in this view, if you have applications that are scaled up, like where they've been partitioned, something that Pramod talked about earlier, you'll be able to see that there are multiple instances, there are multiple containers inside of which the physical partitions of a logical operator are running. So this is a good way to sort of analyze and see how your application is deployed physically across your Hadoop cluster. And one other interesting thing that you can do, if you go to the physical operators tab, which gives you a tabular view of all the physical operators. Let's say we wanted to know at any given time in this complex app what's happening with the data. So you can actually record a sample of your tuples by saying record, and it immediately records all the tuples that are flowing through that particular operator. So this one is an input operator. It only has one connected port, but when you click on the port, you can see the data that's flowing through. So here we can look at the individual the tuples, or we can look at them in aggregate, and you also have ability to filter and search them. So it makes it really easy to inspect your apps, to troubleshoot your apps, see how the data is changing from stage to stage. So that's a really useful feature.
So when you say record, what exactly is that?
Each tuple is a single unit of data that's traveling on a stream.
Okay.
So
what do you record about it?
I was using the term tuple interchangeably with record. What we're recording here is the actual data that's flowing through. What we're doing is like there's a stream. It's processing maybe thousands of events. We pick up a small sample and we show you a sample of that. So what you're seeing there in tuple recording is a small sample of your data.
What is the use of that small sample?
What?
What is the use of that small sample? It won't give you a picture of the entire
The use of it is if you want to understand how the data is changing from hop to hop. Like you're doing transformations, you're doing logic, you're doing computation. Maybe something like you have a long pipeline and in the end there's a wrong outcome and you're not sure what's going on. What you can do is you can inspect data at each point and figure out, oh, this is what's happening here. Maybe this operator is causing the problem. Let me go back and troubleshoot this operator further. So that it's typically for troubleshooting purposes.
But even a small sample is enough to figure that out?
Yes.
Can you develop some visualizations or charts?
Yeah. So let me jump into the visualization part finally. I've created a dashboard which now instead of visualizing the metrics about your apps, I'm visualizing the data for these apps. So this is the same application that's producing these real-time visualizations. As you can see, all these widgets are changing dynamically. What it's doing is it's giving you this is the data side of your app. So it's giving you visualizations on the actual data. We have a app data framework that I'll put in the link in the slides that you can look at further, but it enables these kinds of visualizations, and we have a number of widgets that you can use to produce these visualizations. So for example, for telecom operations provider, may want to visualize number of service calls that are outstanding. You may want to see disconnects that are happening across the network. You may want to see things like what types of calls are coming in. Like you can see other metrics about the dimensional metrics about the disconnects on the network. And also we have charts like that can show you, like in this case it's showing you distribution of usage by the phone on a network. And as you can see, this is all being updated in real time. This is a distribution of the data utilization by device. So you can see the chart here is highlighting that iPhone is really popular in this network. And we have also the geo widgets, which show you how, in this case, it's showing you the disconnects by region. So you can, it's a map of California. You hover over different counties, and it shows you how many disconnects are happening in that county in real time. And here we have a geo circles map, which indicates the wait time averages. So it looks like a lot of people are waiting on this map. So these map widgets, pie charts, bar charts, bullet charts, and other widgets, they can all be added dynamically. You can onto these dashboards. You can go, if you've defined correct data sources for your application, you can go and add the widgets for a particular data source. We have a number of visualizations that are available. It's having a little bit of a hard time loading, but you can basically.
Do you have tutorials on your website?
Yes. Yes. We have tutorials that cover all of these. Yeah. So I think how are we doing on time? Okay. So there's a lot that can be done with these widgets. They're all dynamic. You can move them around. You can change your visualizations. There are a lot of settings and details. All of it is documented. I just wanted to give you sort of an idea of what is possible with the platform, and let you know that you don't need to go out and develop all these visualizations on your own. You can actually just pick up DataTorrent RTS, develop your app. You can even save these dashboards by downloading them, add them to your app package, and if you deploy this app anywhere, the visualizations will come with the app package directly. So you probably can do it. There's some different ways of doing it. You can either embed them maybe with some web technologies. These are all web-based. They're all written in Angular using JavaScript. Or you can write your own custom widgets if you want to by tapping into data sources directly. So you can do that as well. But we've provided an easy way for you to put together any kind of visualization that you want.
So to write custom widgets, you have to write it in Angular?
Yes. To write new widgets, which is something that we're currently working on, you do have to write it in Angular. Yes.
And JavaScript?
And JavaScript. Well, it's the same thing. Yes, it's JavaScript basically. You have to know JavaScript to develop these.
So who are some of your clients who might have to use these dashboards?
Who use these dashboards? So one of the, I'm not sure I'm allowed to mention specific names, but we have some customers in the real-time ad bidding space where they need to visualize data about ads flowing in real time. And they use very similar dashboards to display, like you may want to, so for one of these apps has a dashboard which just shows you like top 10. So this is a popular visualization. Here it's being used for Twitter hashtags when it loads, but you can use it for the ad space as well. I think they use a lot of these types of visualizations.
So for the custom widgets, do you use Angular 1 or 2?
It's Angular 1. Yeah.
This functionality is part of the enterprise.
Yes, yes. So all of this is part of the DataTorrent RTS. It's
Yeah.
Yeah.
So this is the front end of it, right?
Yes.
The backend APIs, are they open source?
Yes, the APIs are open source. We didn't get to this part, but you can actually it's tiny. You probably can't even read it, but you can actually connect to STRAM, Streaming App Master, which is in the Apex space, and you can start. You can both do REST requests to get the data, and you can subscribe in a pub sub manner, which is how all these widgets work as pub sub. They connect and request data, and the data starts coming in, and it's being updated dynamically. So it is available, but again, here it is. With RTS, it makes it really easy because we also, part of the RTS is this gateway mechanism, which sort of app masters get deployed anywhere, and they can go down at any time, and they can get redeployed on a different node, and you have to keep track of where it is to be able to connect to it because the address is changing. It's physically on a different machine every time. The STRAM, yes. But with the gateway knows, it keeps track of all of them, and it funnels all the WebSocket traffic through the same channel on the gateway. So you can subscribe directly to the gateway, which is in a fixed location. Makes it easier even if you're developing your own visualizations, if you're building your own custom widgets. Yeah.
And the App Hub, is that also available for the community, or is it only available?
Yes. So App Hub is currently part of the RTS, but all the apps on there are open source, and we are going to allow down the road for people to add their own packages to the App Hub. We're working on that now. It's a really new feature. We've just released it. We're just playing with it. We want to get some user feedback, and when we feel like it's a little more solid and ready, we'll probably open it up to a larger community where people can contribute their own apps to us. But today you can do that with with the Malhar library. You can contribute code. You can add operators, share them. You can do the same thing with app templates and others. Yeah. Yeah, well, the use case I was talking about is one of our customers, which is in the advertising space, and they're doing real-time ads.
What they're using for such storage, and for example, if you are wireframe transfer,
Storage of?
Currently the market is typically different technologies for this. For example, data streaming software and streaming for example.
Right. So their stack is very similar. We find that most customers end up solving the problem the same way. The streams are coming in as Kafka. Like if they have multiple servers that are serving up ads, usually the data ends up being fed through Kafka. We ingest the data from Kafka. We run all the computation, dimensional computation. All the steps are happening inside Apex, and the visualizations are coming directly from Apex. And then in addition, they're also writing their data to some of the downstream sources, and primarily that is HDFS, and they may have others. I'm not even sure if they have like SQL or some other stores, like databases that they're writing the results to, but all their visualizations are directly tapping into the stream of data as it's processing. So all of it is truly in real time. It's not like you wrote it to a database, then you waited a little bit, and then you got the result later. It's actually, all these are data in motion as it's happening. You're seeing it live.
Okay, so do you have a direct connectors? For example, if I want to take from NoSQL or take from HDFS, just take the data from there and finally just only visualization tool I can use from the data.
Yeah, so you could look through the examples and demos that are available on the App Hub and in our documentation. We have a number of different examples, like the one here with Twitter. We have other dimensional computations that are writing things to HDFS. Where you can see like sales charts, and you can play like slice and dice them every which way. They're not designed for dimensional compute. We have all kinds of examples, so you can go through and take a look at all of them. So I think we're out of time. Okay, all right. Thank you, everybody.